If you look at the plot above, it does have some value, but it is incomplete. It does not have any labels, it does not have any title associated. We don't know what is the X label, what is the Y label, what is the X axis, what is the Y axis, and any other information that could be provided. To make it much more user friendly and understandable, we add title to this plot, plt.title. Plt.title helps you represent or give a suitable message representing your plot. Next, we add the X label. X label represents the name of the X axis. This is our X axis and the name for this axis. The Y label would denote the name for your Y axis. This is your Y axis. And then we call plt.show. So it is the same thing. We'll just call 2 into np.py. Okay. And see, let us have our very first plot with some detailing. You see, this is the y-axis, x-axis labeled, and the name of our plot is my first plot using Matplotlib. So this gives us much more meaning to the plot. Now, how about we want to add two different waves? Say one is sine wave and the other is cos wave on the same plot. So what we do is we again create a the data structure x and y. We call y as np.sin x, y1 as np.cos x. We call plt.plot x comma y, and the second plot we call it just below it plt.plot x comma y1. This will add to the same plot. Why? Because what PLT internally does is it stores the information about the current figure that is being used. What is the figure? The area on which our plotting is taking place, this white area, this is our figure. Okay, so this figure is stored in our PLT object. The current figure object is stored in our PLT object, which and any plot that is added in a particular section or in the same section would add to the same plot. Here, since we are not we could also create a figure explicitly by calling fig equal to plt dot figure. Okay, and use it for our plotting. If we do not give this command, this is implicitly generated by the plt object itself if it does not find any available figures already. We are adding the information here, and let us call the show function. As you see, two different waves are added. One is the sine wave, one is the cos wave to our same plot. Okay, we can also add a legend to it. To add the legend, we also need to give a label here. Sine wave. Okay, and this one is our cos wave. Cos wave or cosine wave, whatever you can call it. Let us see what happens. So you see the legend gives us the information that the blue colored graph or blue colored line is our sine wave and the orange colored one is our cos wave. Okay, what makes this even more interesting is that you could even add this legends explicitly in the form of a list. However, you need to keep in mind the ordering of the plots that you are making there. Additionally, you could also specify color for your plot. Say you want to give a color green to your first plot instead of the blue. Okay, see the color changed to green. If you do not specify the color, it explicitly or the Matplotlib library internally handles the coloring for different waves in different pattern using some range of colors. We have explicitly specified it, so we'll have explicit colors. Next, we will style our plot. We shall specify the width of one of the axes. Okay, so one of the plots. If I want to have this plot as thicker, I'll have it marked as thick. Also, the marker is denotes the symbol that we want to give to our plot. Okay, the color I have specified here green for the first plot. Let me specify the color for the second, which would be red. And the line width I'm specifying is 3. If you see, this green line is thicker than the blue line. Let us see how this goes. If you see this red line, which we gave the color red for the cos wave is having red color, it is thinner as compared to our green line which is representing sine wave, which because we have specified line width as 3.